Suzuki riders have been uplifted by Maverick Vinales' win in the British round of Moto, and by the Moto America Superbike wins of Tony Elias and Roger Hayden this year. But a new GSX-R1000 has been a long time coming. The last engine update was in 2009. Now it's revealed, the all-new 76.0x 55.1mm inline-4 redlines 1000 RPM higher at 14,500, is carried in a Motup-inspired chassis, and is a full suite of modern race-developed ride-by-wire electronics. Plus, for the R model, show is balance-free suspension. I flew to Japan to see the GSX-R presentation and track testing at Suzuki's Seaside Ryuyo circuit. These intros aren't easy. The flight hours are long, and busy lead engineers, required to sit through our questions, would surely rather be in the dyno cells or writing code. For us journalists, the excitement is in the unfolding, realizing what the parts mean, what the numbers and dimensions have to tell. And in being in Japan, Suzuki's obvious goal is to put the GSX-R1000 back on top by boosting engine and chassis performance, by cutting weight, and by helping the rider operate safely closer to the limit through a full suite of electronic rider aids. Etsuo Yokouchi, creator of the original GSX-R concept, said, "Make it faster by chassis design, turn it faster by engine design. Maximum acceleration is set by the point at which the front wheel lifts. Add any more power and acceleration decreases as the bike stands up. Therefore the new engine is moved forward 20 mm by cutting its cylinder angle from 32 to 26 degrees. The new chassis, which is 10% lighter than the previous design, wraps around the clutch on the right to move the swing arm pivot forward, allowing use of a new 40 mm longer swing arm. Engine width sets the ultimate limit to cornering. Even though cylinder bore has increased from 74.5 to 76 mm, crank level engine width has reduced 6.6 mm, and distance between frame rails has shrunk 20 mm. Cylinders are Siamese, meaning they are joined as one, with no coolant passing between. Increased and wider range performance is the overall engine goal. Suzuki's business is sport bikes, so making GSX-RS easier to ride broadens their sales appeal. Therefore increasing peak power was only part of the job. The rest was to make that power easier to use by providing stronger bottom and mid-range performance. Cosworth and BMW both built close to 300 horsepower into 3-cylinder 990cc Motup prototypes, but they were unrideable. The winning play on two wheels is to give the rider confidence through controllable power that gets more out of a motorcycle's rear tire footprint. Suzuki's broad power system for this new GSX-R has 4 elements. The first is conversion from the previous inverted bucket-style valve tappets to tiny finger followers. This, by minimizing valve train weight and making pointy cam lobe shapes unnecessary, allows use of the short valve timing that generates wide torque, plus the high lift that boosts power. The shorter the timing and higher the lift, the higher the valve acceleration must be, which in turn requires minimum valve train mass. An engineer commented that while future increases in cam lift would require larger diameter bucket tappets, to prevent the cam lobe from touching the edge of the bucket, finger followers easily adapt to higher lift. Broad torque is good news, but where's the beef? To get class-dominating straightaway power, this engine utilizes the Senior VVT centrifugal variable intake cam timing system, which Suzuki has used for 10 years in Moto, to delay intake valve closing after bottom center only at higher RPM. This gains top end by letting high intake velocity rush into the cylinder longer. This compact device is built into the intake cam sprocket and consists of 2 groove discs facing each other, with a steel ball in each groove. In one disc, the 12 grooves are radial but ramp-like, becoming shallower with increasing radius. But in the other they are angled. As engine revs rise, centrifugal force moves the balls outward, causing the cam to retard with respect to its drive sprocket. The 2 discs are pressed together by Belleville springs whose pressure, combined with the ramped ball grooves, tends to return the balls to their innermost positions at lower RPM. This allows the engine to be canned for broad torque, with peak power being boosted by a high RPM delay of intake closure by a maximum of approximately 20 degrees. How much power? The brochures we picked through as the PowerPoint images flickered on a screen said max output, and same for max torque. But assuming this new engine peaks 1000 RPM higher than the 2009-16 model, which made a claimed 183 horsepower at 11,500, we can expect very close to 200 horsepower.